Okay, let's talk about the second application of the section 6.3 application, which is application in business and economy. The second application is continuous income stream. We start with a simple example, having an obvious solution, and generalize the concept to examples having less obvious solutions. Suppose that an aunt has established a trust that pays you $2,000 a year for 10 years. What is the total amount you will receive from the trust by the end of the 10th year? Since there are 10 payments for 2,000 each, you will receive 10 times $2,000, so $20,000, okay? So your aunt has established a trust by paying $2,000 a year, okay? So $2,000 for a year, okay? So for 10 years period, the payments, or you will receive 10 times $2,000, which is $20,000, okay? We now look at the same problem from a different point of view. Let's assume that the income stream is continuous at a rate of the 2,000 per year. In the figure 5, here the figure 5, the area under the graph of f of t, which is 2,000, actually f of x here, okay, f of x is 2,000. Let's correct it here, this is t, but this is x. F of t, okay, 2,000 from 0 to t represent income accumulated t years after the start. For example, for t equals 1/4, okay, I would like to enlarge it. So for t equals 1/4, this area give us the income. Actually, for example, if t equals 1/4 years, the income would be 1/4 times 2,000, so which is 500, okay? So this is 500. For t equals 1/2, the income would be 1/2 times 2,000. So this is the total one. This part is 1/2 times 2,000, so which is 1,000, okay? Actually, this one is 1/4 times 2,000, so this is 500. But if income were not continuous, there is no money here, okay? Just end of the 1 year, you will have a $2,000, okay? For t equals 1 year, income would be $2,000. This is clear, okay? So here, for this case, here the money is 2,000. And similarly, you can calculate for t equals 5/3 years. the income would be 5 over 3 times 2000. Okay, I mean somewhere here 5.3 years. So total income is 5 over 3 times 2000, which is $10,600. And when t equals 10 years, you will find this value, $20,000. The total income over a 10 years period, that is the area under the graph of f of t equals 2000 from 0 to 10, is also given by the definite integral. Actually, this can be written from 0 to 1 over 4 f of t dt. What is this one? From 0 to 1 over 4 f of t is 2000 dt. So this is 2000 times t from 0 to 1 over 4. So this is 1 over 4 times 2000. Okay, maybe you cannot follow. Let's write one more step. 2000 times t is 1 over 4 minus t equals 0. So this is 500. So again, you find the same result. So from 0 to 10, the integral gives us the total income. If this is 10, so for the general one, for this region, from 0 to 10, 2000 dt gives us 2000 t times from 0 to 10, which is $20,000. As a result, if you have a continuous income stream, by using definite integral, we can calculate our total income at any time, or between some time interval. Again, you can calculate. I mean, for example, between the 4 year and the 6 year, the total income, okay, this one is from 4 to 6 f of t dt. This is the income, total income in the 2 years period. From, but special 2 years, from 4 to 6. In this example, we assume that the rate of the change of income was given by the continuous function f of t equals 2000 or f of t. It can be depends on t also, there's no problem. This assumption is reasonable. For example, you can find an example in your textbook about the vending machine. Okay, so the vending machine is often collected daily. Okay, so in such situations, we assume that income is received in a continuous stream. That is, we assume that the rate at which income is received is a continuous function of time. The rate of the change is called the rate of flow of the continuous income stream. As a result, let's give the following definition. About total income for a continuous stream. For a continuous income stream. Okay, let f of t be the rate of flow of a continuous income stream. Income stream, that's right. Then the total income proceeding during the period from t equals 0 to t equals a to t equals b. Okay, so then the total income produced during the period from t equals a to t equals b. Okay, geometrically we can explain. We have a rate of the flow for the continuous income stream. Okay, for example, this is the f of x or f of t. Generally, we denote by the t. Y equals f of t. So the total income from A to B this area is total income. Okay, so mathematically, how you can find this total income? The total income equals integral from A to B f of t dt. Okay, so let's continue from the future value of continuous income stream. Okay, so let's write future value of a continuous income stream. In this section 3.1 in first term, we discussed the continuous component interest formula. You can recall also we revisit these topics in this term. A equals P times e to power RT. You remember where P is the principal or present value, A is the amount or future value, R is the annual rate of the continuous compounding, and T is the and R is expressed as a decimal, and T is the time in years. That the principal is invested. So T is the time in years that principal is invested. For example, if money earns 8% compounded continuously, so R should be 0.08, then the future value of 2000 investment in 9 years is, okay, you invest 2000 after 9 years, your future value will be A equals 2000 times e to power 0.08 times 9, which is approximately equals $4,108.87. We return to the trust paying $2,000 per year that your aunt set up for you. The total value of the trust after 10 years is $20,000 is equal to the area under the graph of f of t equals 2000 from 0 to 10. If at the end of each year you invest $2,000 you earned that year at 8% compounded continuously, the amount at the end of the 10 years to the nearest dollars would be equal that one. Okay, the first year, second year, third year, fourth year, it continue by this way. Fourth year, I'm sorry. Fourth year and ninth year and 10th year. Okay, so the future value A for the after the first year there is 0. Here you have 0. Here you have 2000. So this 2000 will be 2000 times e to power 0.8 times 9 because it deposits to 9 years. Okay, so it is invested 9 years period. Here t is 9. For this year you have one more $2,000 third year, so it will be interested for the 8 years. Okay, so the future value of the second 2000 is 2000 times e to power 0.8 times 8. And similarly here for this 2000 t is 7, so it continue by this way, plus 2000 e to power 0.8 times 7 plus blah blah blah. And for the 9th year here we have one more 2000, but t is 1, so 2000 e to power 0.8 times 1. And for the last one we have one more 2000, but t is 0, just we have additional 2000. If you want e to power 0.8 times 0, so which is 1. So this summation will be our future value. Okay, so we make investment, we invest our 2000 for each year. Okay, so this equals approximately $29,429. Okay, if you don't invest, if you don't make any investment, you don't invest your money will be $20,000. Okay, it is mentioned here, $20,000. But after each year, if you deposit your money, your money will be this one. Okay, $29,429. Sorry. Actually, this amount underestimates the future value of the continuous income stream because deposits are made only once per year. Okay, so after this year we deposit. I would like to emphasize one more time. This amount underestimates the future value of the continuous income stream because deposits are made only once per year, not continuously. The future value of the continuous income stream is equal to the area under the graph of 2000 e to power 0.8 10 minus t. Okay, here we have 9. The second year, okay, after 1 year, so t is 1 here. The first year, second year, 10th year, so here t is 1. I write t is 9. T is 9 actually, okay, but this is 10 minus 1, okay. So anyway, the future value, let's write here. It is better to see at the same time. The future value is the area under the graph of 2000 e to power 0.08 times 10 minus t. I am sorry, all of the 0.08 is 0.08, okay? Because interest rate is 0.08. I am sorry, let's correct it. $0.08 times 9, 0.08 times 8, 0.08 times 7, 0.08 times 1. Yes. So the future value is for 10 years period from 0 to 10, 2000 e to power 0.08 10 minus t dt. If t equals 1, you have this value. If t equals 8, you have this value. But at the some point on the this timeline, for example here, you have some money. I don't know. For example, this is 1/4. So you have a $500. So this $500 take the interest. So by using this integral formula, you can find the debt interest. Okay. So in general, let's write the definition. If f of t is the rate of the flow of a continuous income stream, okay, and t change from 0 to capital T, and if the income is continuously invested at a rate R. If there's no investment, actually we calculate by using integral, there is no problem. But now we have some investment at a rate R, compounded continuously. Then the future value, which is noted by the fv, at the end of capital T years is given by the following formula. The future value is from 0 to capital T, f of t, this is the rate of the flow of continuous income stream, e to power r t minus t dt. So this can be considered as a continuous summation. Actually, instead of this sum, we use the continuous sum, that one. Here R and capital T are constant, so you can write outside of the integral. So e to power r times t integral from 0 to t f of t e to power minus rt dt. So this formula can be used to calculate the future value. So the future value of a continuous income stream is the total value of all money produced by the continuous income stream. Income and interest include the both of them at the end of the t years. Okay, so let's emphasize the future value of a continuous income stream is the total value of all money produced by the continuous income stream and interest. At the end of the t years. Okay. Again, I will solve some question in the problem solving R related with the continuous income stream.